Okay, so we can see here that we have a problem that combines the product rule and the quotient rule. And let's start by remembering all of this. So what is the product rule? The product rule is that the derivative of the product of two functions is the derivative of the first times the second plus the first times the derivative of the second. Then the quotient rule is that the derivative of the quotient is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator over the denominator all squared. Also here we should say that the derivative of a to the x is a to the x ln a. We need to remember that. And the derivative of x to the a is a times x to the a minus 1. We should know all these rules very well. And now we can give our solution, and let's try to understand what is going on here. So here we have a numerator and a denominator. And what I want you to understand is that the big picture, even though we have a product on the numerator, the big picture is that we have a fraction. So overall, what we want to apply is the quotient rule. And I remind you that the quotient rule combines, has 5 terms, like so here. In the first parenthesis, we put the derivative of the numerator. In the second parenthesis, we put the denominator, so the denominator doesn't change. So let's put it right away. Then we put again the numerator in the third parenthesis. Where do I see all those things? Right here. So here's where we put the derivative of the numerator, then the denominator, which I just wrote, then the denominator, then the numerator, then the derivative of the denominator, and finally the denominator squared. So every time I apply the quotient rule, I can just write this without even carrying out any differentiation, knowing that in the first parenthesis I have to put the derivative of the numerator, in the last parenthesis the derivative of the denominator. This is a schematic that can help us a lot applying the quotient rule. And now let's start with the easy one, right? The derivative of the denominator. What is the derivative of the denominator? So our denominator is x cubed plus x plus 2. It's a polynomial. Its derivative is very simple. It's 3x squared plus 1. The interesting part is the derivative of the numerator, where we have the sum of two things. X squared times 3 to the x plus 1, right? The derivative of 1 is 0. What is the derivative of x squared plus times 3x? This is a product. This is where we have to apply our product rule. So I'm going to take the derivative of the first, which is 2x times 3 to the x, plus x squared times the derivative of the second, which is 3 to the x ln 3. And like I said, you can always consider that now you write plus 0, but that doesn't change anything and we don't write it. So we can see now clearly here that we have applied our product rule for this inner component, but overall, this is a quotient rule. And that's actually a good idea for such problems. In other words, look at the big picture and then apply other rules as you look at the components of the big picture. Okay, and this is our example for today. Thanks for watching.